Okay, hello calculus students. I thought I would look at one more example of finding volumes, well two more, same problem with two different kinds of cross sections for finding volumes of solids with known cross section. So let's think about the solid formed this time by this function y equals plus or minus the square root shifted to the right and up by 3 and x equals 8. So of course in all problems in this unit you want to visualize first. So let's draw the base region and make sure we're real confident about that first. So it says square root function, two parts of it, but it's shifted right by 2 and up by 3. So right by 2, up by 3, something like that is where the square root shape is drawn. So the positive one is going to be this piece, and the negative one is going to be that piece. Just showing that it does in fact go down and cross the axis eventually, even if square roots grow, or in this case decay slowly, they of course still do grow or decay. So that should kind of make sense to you that it's like a sideways parabola for reasons in a second. It said between those curves though, and also the curve or line x equals 8. So let's see, 3, 4, 5, 6, 7, 8. I don't know that this crosses right there. It's just a sketch. It probably doesn't cross till further on. In fact, I'm going to make that clear. It doesn't decay that rapidly, I don't believe. So somewhere out here, not sure where. Don't need to know. This problem said for part A, we want the solid of known cross section, the volume of that, that's parallel to the x-axis. This is the x-axis. Parallel means our cross sections are going horizontally. So this is the example of a horizontal problem that I've been promising. And it says x equals 8, right? We should be cutting it right there at 8. So there's x equals 8. So we're talking about this base region basically. And first we're going to do rectangles of height 4. I don't think we've done a rectangle yet. I bet many of you will want one for your project. So rectangles of height 4. Let's get our little infinitesimal rectangle dude thing going on here. So there we go. We're going to make rectangles that go up a height that's fixed at 4. And all we really need to know is this distance. This distance is horizontal, so I'm going to call it x of y. We've been calling it f of x that way, or you could say y of x. I guess you could also say x of f, but that's freaking weird notation that I don't really have any experience ever seeing, so x of y is probably good. So this is the key dimension that we're focusing on right here. This is what the whole ball game is about, right? So our integral is going to run y-wise. Remember, this is going to be dy. So we're going to go dy from there to there. So we need to use our calculator to compute those intersections, or do algebra. Let's see if we can do algebra and come up with them. So basically we just need to stick x into there and see if it comes out nice. I bet it doesn't, because I just made this one up off the top of my head. So we're going to come up with plus or minus 8 minus 2. I should have thought a little more in advance and this would have come out nicely. But things don't work out nice in the real world, and probably won't on your project. So that's plus or minus the square root of 6 plus 3. So root 6 plus 3 must be this one. Root 6 minus 3 must be this one. Let's see, 3 minus the square root of 6 is like 3 minus 2 and change. That's going to be positive, so really I should be positive. Yes! My picture's looking good so far. So I'm going to go from the bottom, square root of 6. Oh wait, it's negative. Yeah, I'm right, never mind. Negative square root of 6 plus 3 to positive square root of 6 plus 3. And now, of course, the most important part, focusing on that green cross section. So how long is this? Well, the distance from here to here is the function, whatever the function outputs in terms of x. So this isn't solved for x. Remember, if you just stuck this in here, you should look at that and be like, huh? I'm not doing this right. It's supposed to be horizontal, so I should have y stuff in here. So we need to solve this for y. I think that's a big clue, just the notation. So let's see, if we go y minus 3 equals plus or minus square root of x minus 2. If we square both sides, we'll get y squared minus 6y plus 9 equals, that goes away. So x ends up being y squared minus 6y, add 2, add 2. There's our x curve. So that x curve represents this distance, but I don't want that distance for this problem. I want the green distance. So how do I get the green if I have this? Well, that distance is 8 all the time. So if I want this distance, can't I go 8 minus the x, or horizontal version of the function, and that'll give me what that green guy is throughout this shape. And that's the way to do it. So I want to go 8 minus my x version of the function. This says x equals stuff. That's this x value. See this guy? I'm going to even write a little red underneath it. That represents this horizontal value. If we go 8 minus it, we get the green. So we're going to go 8 minus it. Being very careful to distribute my minus. You know what? I'm just going to go like this. Protect myself a little bit. And I just need to do that integral now. I'm forgetting one other thing. That is just this length. We said what kind of shape? We said rectangles. So the area of each rectangle is going to be that length, this green piece, and this height is fixed at 4. Notice, of course, there's no pi involved in this problem because we're not revolving and we don't have circular types of cross sections. So I really don't want to do this integral. That's kind of the boring part. I guess I'll start and then you guys can finish it on your own. So I guess we can go 8 minus 11, that's what, negative 3? So this is the integral of negative 3y minus y cubed over 3 plus 6y squared over 2, evaluated from this weird number to this weird number, and voila, you'll get your answer. I'm just going to math 9 this baby and move on and set up another problem. So what I got after you math 9 it, let's see, math 9 was negative root 6 plus 3 to positive root 6 plus 3, and I'm just going to type this in right here, I guess. Oh God, 4, factor that 4 out in front, 4. Don't want to forget our 4, or I won't have any volume. That would be bad. Let's see, we're going to go 8 minus 11, I'm just going to say that's negative 3, minus y squared, I'm just typing in x squared in my calculator, plus 6x, or 6y, however you want to say it, dx. If you want to type in y's in your calculator, you certainly can. What I came out with, I'm very much less interested in this final answer than I am the setup, but 596 when rounding. And we're still doing volumes, so units cubed. Okay, so there is this problem if you want horizontal rectangles with height of 4. Let's look at the same problem. We're still parallel to the x-axis, and let's do it with, instead of rectangles of height 4, let's do it with variable equilateral triangles. So I'm going to erase my math. I'm going to keep my picture, mostly, I think. We'll see what we can use. Oh, I think I erased too much. Poo. Anyway, instead of this shape now I'm going to be going with this shape. So now my volume is going to be the integral. I don't think too much changes here except what we're integrating. So we're still going from this point to this point and integrating triangles all the way up. The steepest triangle is going to be, or excuse me, the biggest triangle. It's going to come out at us the furthest right here in the middle, and then they're going to fade down into these edges like that. So we're going from negative root 6 plus 3 to root 6 plus 3. And area of a triangle is 1/2 base times height, dy. So that's going to be negative root 6 plus 3 to positive root 6 plus 3, 1/2. Okay, so now we need to say, what's the base of this? The base of this is that same distance we were looking at in the previous problem. It's this. So how long is this? Well, it's 8 minus the red. So it's going to be 1/2 8 minus, and what did we have a second ago? I erased it. Poo. See if I can do it in my head. You guys will have to catch me if I mess up. I'll do it in green here, right? So it's going to be 8 minus y squared minus 6y plus 9. Let me solve it again, just in case. Y minus 3 equals plus or minus the root. Oh, it's going to be like 11, right? Yeah, I forgot. Okay, y minus 3 squared. So that says x is y squared minus 6y plus 9 plus 2 is plus 11. That should have been plus 11. There we go. So that is the base of our equilateral triangle. We still need the height. Let me get another color going in there. This thing right here. We still need the height, h. So I think we've seen this argument before. If I draw that triangle over here, I'm going to do it one more time for you. This is equilateral, so that's 60 degrees, that's 30 degrees. This is your friendly 30, 60, 90 triangle. So if you remember how to label that from trig, it's 1, root 3, 2, and you can scale these up by any side length you want. So all I have to do here is stick that in. I have it in blue there, so I'll keep it in blue here. So this height is going to clearly be the square root of 3. There's that square root of 3 again for the height of an equilateral triangle, times what I called here s. So what is s? S in this triangle is this much. So it's this green thing all cut in half. So let's go ahead and even color code that. So we're going to have the green thing. You can of course simplify some like terms like we did a second ago, but it's going to be that thing cut in half. This is again that sneaky 2 that we were working on in class and that was causing some of us some issues. So there you go, there's that argument again. Stick that guy in your calculator. I'm not going to this time. Definitely probably want to do this one with your calculator. You could do it analytically because you could just simplify in here, get a parabola, simplify in here, get a parabola, factor out all your constants. What are we going to have pop out? Let's just do that part. So we're going to have a root 3, a 2 there, a 2 there. So we should have like a square root of 3 over 4, if not more. When we simplify this, it's going to be like the integral. I guess I'll do a little bit. 8 minus 11 is, what do we have? Negative 3 minus y squared plus 6y. And then the same thing over there. So it's really just that thing squared, but I'll write it out again. So it's really just that thing squared. You got to expand that all out, get your 4th degree polynomial, and integrate it. So I'm just going to say math 9, get your answer. Be an interesting problem. Is this going to be a greater volume than the rectangle problem or not? I'll leave that to you to finish, and I'll see you next time.